been a lot of discussion about what's the energy impact of meeting ASHRAE Standard 62. And because this home is so carefully monitored and instrumented, we can actually determine what is the additional sensible and latent load that were introduced by the HRV. We know the performance of the heat pump on an hour-by-hour basis. We'll actually be able to perform calculations and document what the impact was. And that's the type of thing that this house allows us to do. Because it's so well instrumented, it allows us to look at these things that builders and building researchers have wondered about, but here we can actually quantify what the impact is.
So one of the issues with a house that's built this type is that you have to start worrying about indoor air quality. One of the big misconceptions is that when people say a building is green, they view it as a healthy building. And that's not necessarily true. Green generally is just describing that it's good for the environment, not necessarily that it's good for the occupants. And so one of the real challenges we had when we were designing this building is we wanted to make sure that we weren't creating an environment that was so tight that anything that would off-gas would create bad conditions. So we can address that challenge in two ways. One is you can ventilate and bring in more fresh air, which we'll talk about in a minute, or two is you can limit the sources in the indoor environment. We've used products with very little emissions, so therefore we've met indoor air quality guidelines for LEED or other certification programs. Very few people actually go in and actually prove that they've met those goals that they've set for themselves. So one of the key aspects that we did at this house that was different from a lot of other net zero facilities is that we actually monitored the concentration of indoor air contaminants for an entire year afterwards. And we have here is a graph that shows some of the chemicals we measured for. We measured for over 35 different chemicals. These are just specifically the aldehydes. And we have a couple interesting things that we've shown is that A, our formaldehyde concentrations are fairly low, which we designed for on specifications, and B, that we also have this diurnal variation in concentration, not diurnal. We have a seasonal variation, thank you. We have a seasonal variation in concentrations. And so in the summer months, we have really high concentrations, and in the winter months, we have lower concentrations. And this is due, we think, in large part, that the emissions are not necessarily from the indoor environment, they're actually from the building envelope. In the indoor environment, we're keeping it at a relatively constant temperature that wouldn't account for this large variation of order of magnitude concentration changes. And so one of the interesting conclusions that we have from this annual measuring over a year is that the building envelope is actually a source of contaminants that we need to be aware of in the indoor environment. In fact, in the building envelope here that's specific and interesting is that to minimize our air exchange and heat losses from convective heat loss through our building envelope, we have, as we were mentioning earlier, a air moisture membrane that envelopes the entire house. And that allows us to get air exchange rates without the HRV down to 0.02 per hour. But the other thing is this specific air membrane has a self-healing properties, and the way it does that is it uses acidophilic compounds to do that. So it uses C16 to C18, or that range of acidophilic compounds. And the interesting thing is that when we did our air measurements, we actually were able to measure C16 through C18 in the hot summer months when the wall cavity was heating up. And these are things that we would think would not necessarily penetrate the indoor environment. So one of the interesting conclusions that would come from doing the research in this house is that not only do we have to think about the source control inside the building envelope, we actually have to think about the building envelope and how that might impact the indoor environment.
We're in a unique situation at NIST because having groups that are focused both on energy, and then having a group that's focused entirely on indoor air quality, both of those groups are involved in this house and very active in Standard 62. In fact, one of the members of the indoor air quality, Steve Emmerich, was the chair of ASHRAE Standard 62 in the past.